Welcome to Microsoft Build 2017. I'm David Lee. I'm a program manager in the developer platform at Microsoft.
I'm Robert McCallan. I'm a software engineer.
And today we're talking to you about performance. At Microsoft, we're invested in making performance a key aspect of the operating system. And this is also reflected in the controls that we provide to our developers. So no doubt that you've heard about our new design language and a lot of the powerful animations, effects, and beautiful design that's part of it. Before you go off and unleash your creativity on your apps, here are some tips and tricks to keep in mind in relation to performance so that your beautiful app can also be zippy and fast. Today, we're going to be covering three broad categories. First, we're going to talk about images, and loading UI elements in lazy loading sort of way. And then we're going to move on to effects and lights, specifically XAML effects and XAML lights, and how to tailor those for customers running on old hardware or for people who are on battery power who might want the additional minutes of battery life. And then we're going to move on to features in the visual layer, relative size and relative offset, which we added for the Creators Update. So let's get started by talking to you about xLoad, which is a new XAML feature we've added for the Creators Update. And why don't we just dive straight into a demo on the other machine?
Great. So here, what we've introduced in the Creators Update is the concept or attached tribute of xLoad. And xLoad is now a replacement of what was introduced in the Anniversary Update, which was delay load strategy. And this is something that you should be using if you have views or content in your page that shouldn't be loaded at the start, or maybe usually not loaded. It might be loaded in a specific scenario or much later in the life cycle of your application. And to contrast this, I have one container setting visibility to collapsed. And then I have some children, one of them setting their visibility, the other one not. And then I have a grid here that uses the new xLoad technique. And it has some children. And the last two children also apply xLoad. So if we run the application right now, what we'll see is that they both create the same visual results, which is neither of them will be on the page. So we'll see that right here. And all we see is the button and the checkbox. But the difference is that if we use the live visual tree, which is a great tool to see what's actually in your XAML application, then you'll see that that stack panel is there despite setting visibility to collapsed. And this is because setting the visibility to collapsed or the opacity to 0 will not change whether or not the actual UI elements are loaded. And not only that, if we expand the stack panel, we'll see that both text blocks are there. So even if they set their visibility to collapsed, they will still load, and your users will pay for those UI elements.
Right. And here, it might not be such a big deal because you only have maybe 2 text blocks. But we've seen in general in UI that there are applications with huge swaths of their visual tree in visibility collapse at the beginning. And when menu items are selected, they become uncollapsed.
And that's just using xLoad here instead of visibility collapse is just an easy performance win for developers. In fact, there's an even easier way to audit your code to find out which places you should be using xLoad. So here, if you dive into these settings and you check UI analysis, you'll see that there are some new events that you might have not seen before. And here it's seen that both our stack panel and our text block have our visibility set to collapse. So they're telling us that setting them to collapse or opacity 0 will not prevent the element from being created. And these are great ways to do kind of an audit of your code and to see what are some candidates for using xLoad. Additionally, if you use the defer load strategy anywhere, you should change that over to xLoad. The way that they're different is that the deferred load strategy allowed you to defer the creation of the UI element and its children, but did not let you unload those elements. And here, xLoad allows you to do that. So here on these last two children, we have xLoad actually bound to the checked property on our checkbox. So we'll see here that when we press this button, the deferred grid shows up. And the way that shows up is that we just reference it by name. Name is required if you're going to use xLoad. And just referencing it by name will populate it in the live visual tree. And now you'll see it has 3 children. The last 2 children are not there because it still respects the xLoad property. And now when we click this checkbox, a new child should show up, but not the other. So we see that. The 1 rectangle has shown up now. And now if we uncheck this, that rectangle should be unloaded, and now the new rectangle 2 should be loaded in. And we see that happen as well. So this is a great just a performance optimization to use if you were using defer load strategy. And then there are some additional benefits to get if you were using visibility collapsed.
And this is also a great example of where you have nested case, because it is an X load within another X load.
Right. So yeah, if you have a subtree and you have their own conditions on when they should be loaded and when they should be not, X load will totally work for you there. So I'll hand it back over to you, David.
Great. So now we've covered Xload in loading UI elements. Now let's talk about loading something slightly different. Let's talk about loading images. And a lot of the image guidelines that you should be thinking about when you're creating your apps. So some refreshers on XAML image practices, best practices while we get the demo set up on the machine. Some things to keep in mind is that you ideally want to use vector graphics when possible in any cases where you can, in order to avoid adding multiple large image assets. So iconography is a great place to use vector graphics. And this is made easier now because we now support SVGs in XAML markup. So you can just put the SVG file in and load it in. Also, the second tip is when you're loading bitmap images, remember to specify the decode pixel width and decode pixel height. So this is an optimization that we already do for you when you're loading square or rectangular XAML images, so the default standard images. Recently, we've seen a lot of designs in UI where you have circular images, where you have images hosted in containers of other shapes. And for these cases, we don't yet optimize the decode width and height. So what that means is, like, if you have a huge 10,000 pixel by 10,000 pixel image and you only want to show it in your app as a small thumbnail, a small icon, the entire thing will be decoded, rather than if you specify the decode width and height, it will only be decoded to that size. So if you're only showing something that's 100 by 100, you specify that as your decode pixel width and height, and that saves significantly on memory footprint. And then finally, this is just a reminder of previous features that we've added, but when you're using lists and grids, remember XPhase. You want to prioritize loading of the most important content first. So XPhase, XBind can be used in conjunction with everything that we've mentioned before. We've mentioned before in this talk, and that we're going to be mentioning throughout the rest of this talk. And so remember to use XPhase. And now we're going to jump into another demo for loaded image surface, which is something new we've added for the creators update. And we switch over to the other machine to see the demo.
Yeah. So longtime users of the visual layer will know that manipulating a bitmap requires you to draw your surface or draw your content into a surface using D3D or D2D, or a very popular option is using Win2D, which wraps direct 2D. And before, this required you to take on a lot of responsibilities. Just on a very surface level, no pun intended, on looking at these different objects that you'll have in play, using the new technique, which we'll cover in a little bit, you only have the one surface that you have to worry about. And you see here that loaded image surface actually implements eye composition surface.
Right. And a good thing to call out here is that this is for a lot of our power users who are diving into the visual layer, who are working with surfaces.
If you're building your own visual tree and you have your own surfaces, this is for you. If this looks kind of foreign to you, don't worry. That just means you're working purely in XAML, and there's absolutely nothing wrong with that. So what you also have to handle in the manual case is that you have to create your D3D device. So in this, this is what the canvas device is in Win2D. And then you have to create your composition graphics device, which is a composition concept. So if we jump into the code in the manual case to see what you had to do before, you had to create your D3D device. You had to create your graphics device. You had to then load the bitmap that you wanted to use. And generally, you would use WIC, but in this case, Win2D handles this for us. You have to use the create a drawing surface off of the graphics device and specify the correct pixel format and the correct alpha mode, and then you have to draw it. Even with all of that code, there's still more things that we should have handled in this sample, like handling device lost. So if you have a customer who's using a Surface Book and they have a dedicated GPU model, and they disconnect the Surface portion or the tablet portion, they would go through one of these device lost cycles. But there's also many other reasons why someone might go through this.
Right, and as a developer, I might not know if I'm not familiar in this space, to test for device loss.
Right. These are responsibilities generally relegated to a framework. and that if you were doing things by hand, and there are some scenarios where you may still want to do that if you have some crazy D3D shader that you want to use. But these are responsibilities you have to be aware of. Another responsibility is the app lifecycle. So if your application is taking up too many, or is suspended, you should free up those resources to make sure you don't take up too many resources, so that you don't give the PLM a reason to come and terminate your application while suspended. All of that code, including the stuff that we haven't written for the sample, can be replaced with one line. So you just call loaded image surface dot start from URI or start from stream if that's what you're using as input. Provide it what you're using to load in the image, and then not only will the entire drawing and creation of the surface be handled for you, but device loss will be handled for you, and so will the app's lifecycle events. So really, everything is handled for you, and if you're going to be using XAML in conjunction with the visual layer and crafting your own visual trees, you should absolutely be using this. And if you have a really custom scenario, that'll come up, and that's still fine. But here you're avoiding creating D3D devices, having to keep them alive, and handling things like device lost. And now I'll hand it back over to you, David.
Great. And so you've loaded your image now. You have images in your app, and now you want to add some of the fancy lights and effects that you've seen in some of the other sessions. Here are some things that you might want to keep in mind. So we've added XAML effects and lights. You can now use composition effects and paint XAML elements with those composition effects using the newly introduced feature, XAML Composition Brush Base. And when you're doing that, there are on-connected and on-disconnected overrides that we'll see later that you should be using in order to create and dispose your composition objects so that you only create them and when they're needed, and you dispose of them when they're no longer needed. And from a design perspective, we can't stress this enough. When it comes to blur, lights, and shadow, less is more. Blur, spotlights, and shadow are a few of the effects in particular that are very powerful, and they can have power and performance implications if they're overused. So to make it easier for you to adapt your app for people on different types of hardware, we've created effects fallback APIs, composition capability APIs that checks to see if the user's machine, there are certain older pieces of hardware that do not support composition effects. So we check to see if the machine supports it or not. If you do not check, there is a chance that the people who are on older hardware may not be able to see your effect. So you can add blur and lights, and those just won't show up. So it's great to check for those things in your particular app. There are also power management and energy saver status APIs. These are not new, but these are really useful for tailoring your brushes for situations where developers might want to, or the user might want to save on their battery, like when they're in battery saver mode. So let's jump into the demo. Let me just open it up. And so this is the code, and I'll run it in just a second. But you can see the XAML is pretty basic. The XAML has an image that is loaded in the background, standard XAML image. Then on top, there is a grid that is 250 by 250, so it's a small portion of that we're painting with what we're calling the demo brush. And demo brush is very simple. We open demo brush, and it inherits from XAML Composition Brush Base, which is what we've introduced in the Creators Update. Here, we are creating the objects associated with this effect in the onConnected method.
OnConnected and OnDisconnected are two very important pieces of this part, because OnConnected and OnDisconnected are basically hints from the XAML framework to let you know when that object is being in use and when you can reclaim your resources. If you just create them in the constructor and just kind of hand wave the lifetime away, you can be using up precious resources when you don't need to be using them.
Right. And then we check for composition capabilities. So this is the composition capabilities.get for current view. We call our effects supported and our effects fast. So again, effects are supported when you have hardware that supports effects, period. So if this returns false, that means you can't use composition effects. We recommend you do something else to make sure that that experience is not broken. Our effects fast are certain combinations in which effects are not super recommended in certain settings. Like if you're in a VM environment, effects fast returns false. Because in general, you don't really want to be running all of these fancy effects.
And here we've kind of condensed those down to one case, but you could create a 3-tiered system where effects are supported, so you may use something cheaper like an invert effect, but then if effects are fast, then go all out with your blur.
But for demo purposes, because I can't easily change hardware on the fly, we're also calling the PowerManager.EnergySaverStatus API. So here we've hooked into EnergySaverStatus PowerManager.EnergySaverStatus which fires when you go into battery saver mode or when you go out of battery saver mode. And so here, when battery saver mode is off, so is not equal to EnergySaverStatus.on, when it's off, we create a standard effect. And we can see that this is just a backdrop brush with a Gaussian blur. So Gaussian blur effect, very simple. And when battery saver status is on, we go into create fallback brush. What is this fallback brush? For the purposes of this demo, it is just a brush with a color green.
You might use like an image or
something with opacity.
Yeah.
And when you're handling the particular energy saver status changed event, you can also add animations so that the transition is not as disjointed. But here we wanted to show you, we wanted it to be really obvious.
And one thing before you jump in, you can see on the in the event handler we're using the dispatcher to do some work, and this is because this will not actually call you back on the UI thread. And if you're going to make changes to XAML objects, which you would be because you're inheriting from XAML composition brush base, then you want to be doing those from the UI thread. So make sure you call out to the dispatcher to do those things.
Right. So let's run this app. OK. And here we see just what was described before. There's an image in the background. There is a small grid, and that grid is blurring the background. Great. So let's see what happens when we turn on battery saver mode. So I'm currently plugged in. Let me just unplug my Surface and turn on battery saver. And now we see when battery saver status on, that blur becomes a green tile. And so you might imagine this to be a menu where you have a ton of these tiles, and each of them has blur. Then when you turn battery saver status on, say I'm on an airplane, and I really want to get that last few minutes out of the battery, you might want to transition to something that uses less power, have some consideration for the user is always appreciated.
And what's really great is that if you're actually consuming the events, you don't have to restart the application to see the changes. So if you're on the flight, you're in battery saver, everything turns to whatever you've chosen. Here it's green. But then when they get off the flight, they plug back into power, they get their effects back. And this is also a great pattern to use if you want to give the user a toggle in, let's say, the settings of your application to just turn on and off effects. Then you can create your own infrastructure for that setting flag as well. And it just gives you a nice centralized place to handle all of that state.
Great. Yeah, I'm just going to toggle this a little bit more so you can see that, yes, it is consistent. It continues when you plug it in. When you don't, let me just plug in my computer again, and you can see that it turns back. Right. All right. So that is adaptive lights and effects. And now we're going to be diving a little bit deeper into the visual layer. And so this is for those who are working in the visual layer for some advanced scenarios. And previously in the visual layer, you were only able to specify a position, like offset and size, via in absolute coordinates. And we've noticed that a lot of people have been using expression animations to arrange the visuals in the right place with the right size.
Commonly using ratios dependent on a different visual size.
Right. And we wanted to make that easy. So before, it's completely possible and it's performant with expressions. We wanted to make that experience easier. So we've added relative size adjustment and relative offset adjustment, which allows you to specify the size of your visual relative to the size of your parent. And so there are a lot of benefits, including performance benefits. It's much easier to use, as we'll see in the demo. But rather than walking you through all of that, let's just go straight into the demo on the other machine.
Yeah. So here, the application that we're going to be demoing is just a grid of visuals. And when you resize the window, they kind of change size accordingly and change their position. And the same thing's happening with relative size and relative offset. Now, jumping into the code, we'll see that we're setting this up per visual. And we see that we have to do a lot of string concatenation. We're setting up our ratios. We have to make sure that we set the correct reference parameters so that the correct visual that we're referencing, we actually get those changed events inside of the compositor. And again, you have to do the same thing with offset, and then bind them as two separate expressions onto usually one visual object. And this is just a lot of work to be going through. And if you have a scenario that can be easily explained as ratios based on your parent size, this is where a relative size adjustment and relative offset adjustment is kind of a quick short path for that.
Right. And it's important to note for those who are familiar with expressions, this is kind of like a naive way of doing these types of expressions,
right,
because these expression objects can be basically templated and reused. Here we're not doing that for demonstration purposes, but also because we do see that there are some users out there that tend to use expressions in this way.
Yeah. So here when we go to the relative version, these are two properties on the visual base class, and there are a vector 2 and a vector 3. And they're both expressed as percentages or a ratio of your parent size. So if you want to be 50% of your parent size, you would set your property, your relative size adjustment to 0.5, and that would make sure that you are 0.5 of your parent. If you want to be offset 30% of the way into your parent, then you would set your relative offset adjustment properties to 0.3, and it would position you accordingly. Whenever those things change, the compositor will know on the same frame that it changes and update the sizes of the other visuals. So there's no worrying about having to hook up to size changed events and managing that state on your own. And here we see that we've set up these ratios based on the column and the row. And we only have to set those properties once, and we can, much like the expression animations, walk away from them and not have to deal with them until we want to actually change the fundamental ratios themselves. And here we'll just show you again. The orange is when they are using expressions, and the green is when using relative size and offset. And this is just to show that you're not missing out on anything by using the fast path, or I guess the faster path. But it's just one thing to keep in mind when constructing your layout when working with the visual layer.
Right, and you can imagine that when you are working with more complex layouts, right there, it was mostly a grid of visuals. They're fairly uniform, so the expressions could be fairly simple. When you're working with more complex layouts, that's when relative size actually shows its simplicity. Right. And that's where we recommend it. And expressions are great for handling more advanced scenarios where you don't, it's not just layout that you're after.
Right. Back to you, David.
Great. And so we've talked about sizing now. And so that brings us to the end. So far, we've covered images and lazy loading of UI elements. We've covered effects, lights, and how to tailor those effects and lights based on hardware of the user and based on the battery saver status. And then we've talked about an advanced feature in the visual layer, relative size and offset adjustments, that allow you to more easily arrange and more performantly arrange visuals in your application. So now that you know how to do all of these performance tips and tricks, and you've looked at some of our the awesome aspects of our new design language, we want to hear from you. So tweet us your awesome and performant UI creations at Windows UI.
Or if you have tips and tricks of your own for performance, tweet us those as well.
Right, we'd love to hear from you. You can also play with our sample on our GitHub repository. The links will be in the PowerPoint slide, and that can be found below this video on Channel 9. Visit other build recordings and continue your education at Microsoft Virtual Academy Online. Here are some other talks that you can go check out if you want to learn more about Windows UI or composition features. And I highly recommend you go check out the performance articles on Windows Dev Center. They cover a slew of different topics, from grid view and list view optimizations to optimizing layout to keeping the UI thread responsive. And of course, we've previously had talks on Channel 9 about performance, and a lot of those are still true. So feel free to go take a refresher. I've linked one of the articles from a couple years back, but there's also a lot of great content out there. Feel free to check it out. And hopefully, we've convinced you that the UI that you make can be both beautiful and performant, and that they're not mutually exclusive.